By clicking on the channel menu button, a DSG wave menu will pop up. The upper portion is basically a shortcut to the same menu items in the main DSG menu, such as signal type, frequency, and amplitude. 2 additional parameters can also be set here: the initial phase, theta, of the signal, and the random seed which is used to randomize as the Gaussian white noise. The duty cycle of the square wave is default to 50%, and it can be changed to other number in the channel menu here. The lower portion of this menu provides more options for generating more complicated DSG signal. The first option is narrow band random signal. In this case its phase theta, t, is no longer constant phase. It becomes a slowly drifting phase as function of time, which is created in DSG by Lopus filtering of the Gaussian white noise. 3 parameters are required for the generation of this narrow band random signal: the standard deviation of instantaneous frequency, which specify how much the frequency is fluctuating. This parameters is proportional to the bandwidth of the PSD peak of the NBR signal. Let's enter 10 Hz for channel 1. The expected frequency of the instantaneous frequency, which will specify how fast the frequency is changing. Let's enter 5 Hz. Also enter the filter order of the Lopus filter. In this case, enter 1023 here. There are 3 output options. The first one is the signal, which is the narrow band random signal xt. The next one is the instantaneous phase IP, t, which is the intermediate information theta, t, in degree. The third option is the instantaneous frequency, which is also the intermediate information, and is equal to the center frequency f, plus the time derivative of the instantaneous phase. Let's select signal as the output. Click OK to return to main menu. For channel 2 and channel 3, the same narrow band random setup will also be applied. Now click play to generate the time history and PSD of this narrow band random DSG signal. The time history and PSD will start showing the effect of narrow band random. The bandwidth of the PSD peak now becomes broader than the periodic signal. The tracking frequency in reference window starts showing some fluctuation and is no longer constant. Such narrow band random signal now resembles an engine vibration signal, in which case the RPM tend to speed up or slow down momentarily due to the load variation on the rotor.